that wall is. This is called a gram-negative cell wall. Take a look at how small it is. But both of these organisms, indeed, gram-positive and gram-negative organisms, indeed have cell walls. I told you that penicillin, well, let's stop and understand something. You understand that I gave you this analogy that if you build a wall with bricks and no mortar, you just push the bricks over, right? Because what is the mortar? It's the glue that holds the bricks together, right? So the glue that holds the bricks together, if you give a patient penicillin, now this wall is very, very weak. This wall is also very, very weak, except there's a problem. Penicillin, well, there's a membrane, there's a typical cell, well, notice that there's a couple cell membranes here, but number one, penicillin can get to this cell wall very easily. Sometimes it's harder for penicillin to get to these cell walls. Number two, which organism do you think the cell wall plays a larger role? Gram-positive or gram-negative? Gram-positive. If you take away this organism's cell wall, look at how many, you've got two other phospholipid bilayers to help keep this organism at least intact. You destroy this cell wall, you only have this left. And because the cell wall is so large, it plays a very, very important role in the life of this organism. So do you understand that if you give penicillin to this organism, number one, it's probably not going to work. Number two, if you did destroy the cell wall, the organism might still stay alive. But here, when you use penicillin, it works. It works most of the time.